Welcome once again on a series on cyclic geometry. Our first theory is the theory on angle at the center being twice the angle on the circumference. Now, what do we mean by angle at the center? By angle at the center, we are referring to this angle here. That's the angle at the center, provided this point is your center. So that's the angle at the center. And this one is the angle on the circumference, provided this vertex is on the circumference. Now, let's try to establish the relationship between these two angles. So to establish that relationship, we are going to construct a line from this going through that. And then let's call this angle here angle X. And then this angle on the other side, we are going to call it angle Y. Now, from there, what do we notice? This side is a radius. So it's going to be equals to this radius, and this equals to that radius. Now, if this is X, that is this triangle here. Let me try to highlight it in blue. This triangle here, the triangle I've just highlighted it's an isosceles triangle. If this is an isosceles triangle, the base angles are going to be equal. So in this, it must be equals to X. Same applies to the other triangle. So for the other triangle, if this is Y and this side is equals to that, so that triangle is definitely an isosceles triangle. So if that's an isosceles triangle, this angle down there is X. Now let's review some theory on angles of a triangle. Let's review some theory on angles of a triangle before we move further. Let me come just here. Let's say you have a triangle here. Let's say you have a triangle like this. So for this triangle, let's say this is 30 degrees. This is 70 degrees. And then the question says, find that angle there, which is X. First things first, you might say, okay, I have an angle, I have this angle, I have this angle, and I'm looking for this interior angle. So I can just sum all of the three angles up to get 180 degrees. Sorry for that. So 30 plus 70 plus the unknown angle there. The unknown angle there should give me 180. Those are some of the interior angles in a triangle. 70 plus 30 is giving me 100 plus the unknown y is equals to 180. Then subtracting 100 from both sides of the equation, I'm going to subtract 100. So what's going to happen here is that this 100 and this one, they are cancelling out. And then on the left hand side, I'm left with y is equals to 180 minus 100, giving me 80 degrees. So this angle here, it's 80 degrees. Then from there, I can use the concept of angles on a straight line. So for angles on a straight line, they should give me 180 degrees. So this plus the x there. So the 80 plus the x should give me 180. Now from there, let's subtract 80 on both sides, subtracting 80, and then on the left, this 80, it's going to cancel this one. Then I'm only left with x. I'm only left with x being equals to 180 minus 80. This is 100. So this exterior angle here that I've called x, it's actually 100 degrees. So instead of wasting time first finding this and then finding that, there is a theory which says the exterior angle of a triangle is equals to the sum of the interior opposite angles. So if this was my x, I could have just written x is equals to the exterior angle is equals to the sum of the interior opposite angle, interior angles, these two. So they are 30 plus 70. It's giving me 100. That's actually a theory. So this x is equals to this angle plus that. So this plus this should give me this one. That's actually a theorem. Now let's try to apply that theory on our sketch just above. Now we have this angle and this one. We want the exterior angle here. So the exterior is equal to the sum of these two. So this and this is x. So to find that angle, I'm going to say this plus this. It will give me this angle there. So x plus x is 2x. So this angle here is just 2x. Same applies to the y. It's going to be this angle here plus this one. This is supposed to be y, not x. Sorry for that error. That's supposed to be y. So this plus that, it's giving me this one. So even here I'm having 2y. So now let's check this one. The sum of these two angles, it's x plus y. So at the circumference, I have x plus y. And then what's happening at the center? I have 2x plus 2y. So what if I decide to factor out 2? From there, I'm going to get 2 into x plus y. But then x plus y is actually the angle at the circumference. And then this is the angle at the center. So in other words, we've now established that this angle is actually a half of this one. Notice this is 2x plus 2y and this just x plus y. So this is 2 into x plus y. And this one x plus y. So overall, we have that here it's x plus y. And then here it's 2 into x plus y. So basically the angle at the center is twice the angle on the circumference. Angle at the center, it's always twice the angle on the circumference. If you multiply the angle on the circumference by 2, you are getting the angle at the center. Now let's try to look that from GeoGebra. Now let's go straight to GeoGebra to view that in practical. First things first, I'm going to take you through how to construct a circle from GeoGebra, or rather on GeoGebra. Let's just say we want the center of the circle to be at the origin. Just place a point at the origin. And then there are different options for circles here. The first one, you just choose the center and then you'll be moving out like that. Then there is your circle. Then you must place a point where you want it to go, but that is sometimes not giving you accurate results. Let's go for the second one, whereby we are just going to click the center and then enter the radius. So let's say 5, and boom, that's a circle. Let me remove this one because I don't need it for now. And then let me do this. Just a quick one. There you go. Then let's try to measure the angle. This one. That's the angle, it's 106. So the angle at the circumference is 106. So the angle on the circumference was expecting it to be half of 106, which is 54. Sorry, it's 53.13. There you go. That's 53.13. Now let's try to be playing around with this GeoGebra. Let's try to be playing around with this, our GeoGebra. Let me try to increase the font just a little. Font, where are you? Nice one. Now, if I decide to move this one there, so the angle at the center, it's 143. Half of 143, it's giving me 71.57. Though these ones are not 100% accurate. If you divide 143.3 by 2, you are getting 71.56. 71.565. It's rounded off, so that's why it's 71.57. So move around this one. So the angle at the center, if you halve this, you are getting this, and then if you multiply this guy by 2, you are getting this. 53.06 times 2 is giving me 106.12. So this one has been rounded off. That's why there is some kind of an error here. Those numbers are rounded off correct to 2 decimal places. So that's why we are seeing that. So, but then bottom line, angle at the center, it's always twice the angle on the circumference. Now let's check this. I'm having 200.38 here. Then there is 100. So for this one, there is sometimes a temptation from our examiners. Sometimes they will be giving you this angle here, and then require you to find that, let's say this angle was not there. You are given this angle that's there. Then you are required to find. Some student would be tempted to say 159.62 divide by 2 and say it will give you those. But then please take note of this. it must be the angle on the outer, giving you the angle on the outer there. So it's always this angle is there, like that. Show this one. So half of this gives you this, double this, you get that. So basically that's the angle at the center being twice the angle on the circumference. Now let's go straight to examples on these ones. So our first example, you are required to find x, and then x is at the angle on the circumference. So if you double the angle on the circumference, you are getting the angle at the center. So in our case, the angle at the circumference is x. 2 times x give me 2x. This should give me the angle at the center, which is 80. Then from there, let me divide both sides. Divide this by 2 and that one by 2. If I divide this one by 2 and this one by 2, I'm getting that x is equals to 40. So the angle here is 40. So if you multiply 40 by 2, you are getting 80. Next example, we have an angle at the center being x, and then the angle at the circumference being 50. So the angle at the circumference times 2 times the angle at the circumference is 50. This should give us the angle at the center, which is x. And then 2 multiplied by 50 is giving me 100. So the value of x there is 100. Next, we need to find x there. What's the value of x? Like we've tried to mention, it must be this angle on the outer here, giving us that angle on the outer there. Like that, this angle to that. So what's the value of this? And we need to first find this angle here. So, but then let's try to recall some theory. Angles around the point, they give us 360. So if we just take away 88.84 from 360, we are going to get the angle here. So let's start with that. So 360 take away 88.84. This is going to give us 271.16. Now we have the angle on the center, at the center being 271.16, a reflex angle. Then we need to find the angle on the circumference. So the angle at the circumference multiplied by 2 times the angle at the circumference is x. The angle at the center is 271.16. Then from there, 2 times x is 2x, being equals to 271.16. Let's do the necessary stuff here. Let's divide both sides by 2 to isolate the x. Divide by 2, divide by 2. Let's divide this one by 2, divide by 2. So if we divide by 2 there, these 2 will be cancelled out by this one here. And then on the left hand side, we will be left with x being equals to 271 divided by 2. It's 135.58. This is giving me 135.58, which is the angle there. And then next example, so this one here. Let's try to identify the angle. The angles here. This is the angle at the center. This one here, angle at the center. This one here, angle on the circumference. So the angle at the center is 2 times the angle on the, so the angle at the circumference in our case is 50, also 2 multiplied by 51 should give us the angle at the center, which is x. Then your x should be equals to 102 degrees. So here you have your 102. Just like that. And that marks the end of our first tutorial on angle at the center being twice the angle on the circumference. So the angle at the center is twice this angle on the circumference. Our next theory, theory number 2, we are going to establish the value of an angle subtended by the radius. We are going to apply this theorem in finding the value of an angle subtended by the radius. Stay tuned for more.